Okay, today we will start with next chapter, that is about quadratic equation. For this chapter, to understand this, you have to read first about there's one chapter in your textbook, chapter 2, that's about polynomial. But first I'll do this chapter, quadratic. Because in that last video I have sent you about the factorization of a quadratic equation, and here also in that same topic will be there, but here we will learn mainly about quadratic equation, and this equation I am using in day-to-day life by application. And first, what is a quadratic equation? Remember, the equation which always has two zeros, the equation which always has two solutions, and that is the degree of that equation is 2. If the degree of the equation will be 2, then that always we call as a quadratic polynomial, and if it is equal to 0, then all that will be called as quadratic equation. Okay, example, if I write this 2x squared, example 2x squared plus 3x, then plus 3x minus 6. Example, now 2x squared plus 3x minus 6. Is this a quadratic equation or a quadratic polynomial? Look, whenever we write like this will be called as quadratic polynomial. This is called what? Quadratic polynomial. And if the same equation, if the same expression I will take here, I'll write 2x squared plus 3x minus 6 equal to 0. Now this whole equation I equate to 0. Then this will become as quadratic equation. Now don't confuse what is a quadratic polynomial and what is a quadratic equation. Quadratic polynomial is just like the expression of any equation. The expression of an equation which has a degree 2. The equation, we express it as a degree 2, but once that expression are equal to 0, means this we call as expression. That I only give some videos about introduction to algebra. Then this we call as algebraic expression. Then this algebraic expression, it has a particular name, that is quadratic polynomial. Why called quadratic? Because the degree of this expression is 2. Okay, but now this whole expression, quadratic polynomial, if we equate to 0, then we call that quadratic equation. Then if f of x is equal to 0, then this will be called as, now if I just write f of x, then this is a polynomial. But if I write f of x is equal to 0, then this will be called as quadratic polynomial, a quadratic equation. Remember, any equation which are equating to 0, that we call as equation. But if you just write, if there is no 0 here, then we call as expression. Got it? Then, now but first, we'll learn if I give you different types of equation, how we can identify them, which are the quadratic equation and which are not a quadratic equation. If example I write this, ax plus b is equal to 0. Is this a quadratic equation? This is not a quadratic equation. Remember, for quadratic, the degree should always equal 2. The degree should always equal 2. But here what's the degree? Here the degree is equal to 1. Then this is not a quadratic equation or not a quadratic polynomial. This will be the linear equation. Okay, now let's start with that, how to identify which are the quadratic equation and which are not quadratic equation. Okay. Okay, now let's identify which equation are a quadratic equation and which they are not. Okay, first before we go there, let's write the standard equation of quadratic equation. Okay. Quadratic equation, or we can write as standard equation. Okay, standard equation of quadratic. Please, every equation, whatever they give you, please compare it with this equation. Okay, I write that equation. That is ax squared plus bx plus c equal to 0. Now all these are equal to 0. Then it becomes quadratic equation. But if I just write like this, ax squared plus bx is equal to c, then this will be as a quadratic polynomial. But this has quadratic equation. And remember, this a will be the coefficient of x squared. A coefficient of x squared. Now this a will be a constant value. Okay. Now then this b will be coefficient of x. In that last video that I showed you about the factorization, this term I call them as a sum or add. Because here sometimes we add the value or sometimes we do the subtraction. Okay, then this part will be called as the constant term. Constant term. Or in that last video I have called this as a product term. Because here when we do any factorization, we'll find the value which number when we multiply we get this, and when we subtract or add it we get this b. That's why I told them this part as the addition or subtraction. Then this part will be product term. This will be the product term. Okay, now this will be the general equation of quadratic. But now, what are the conditions required for the equation to be quadratic? First one. Okay, condition required. Condition required for the equation to become quadratic. First, number one, the degree should be what? 2. What's the degree? The degree of the polynomial or the given equation. The degree of the polynomial or the given equation should be 2. And then number 2, it should be in this form. It should be in this form. This will be the standard equation of quadratic. Okay. And then remember this x will be the, you remember this? What is that x? That x will be the variable. And remember, the power of the variable, mean this, power 2, and here is power 1. The power of the variable should always be a positive integers. Mean the power of variables. This x will be called as variables. Maybe they put in place of this x, they put as y or z or whatever it is. Okay, but the power of this variable, the power of variable should be a positive integers. Should be a positive integers. And positive integers, you already know what is positive integers. That is 1, 2, 3, 4. This will be the positive integers, or I can call them as a natural number. Okay, positive integers. And one more. And one more. The power of this variable should not be in a fraction. Because if it is in a fraction, then it won't be on positive integers. Because integers, there is no number in fraction. Fraction you have is 1 by 2, 1 by 3. Then the power of x is x. The power of x, we should not write like this. If I write x to the power half, then this is not a quadratic. Okay. Then if you got x to the power 2 or x to the power 1, here x power 2, here x power 1, then that will be a quadratic. But if here x is x power 2, but here we got x to the power minus 1. If you got here x to the power minus 1, then still that also not a quadratic. And if you got here also x to the power minus 2, then this also not a quadratic. Then if you got example root x, that also not a quadratic, because this root are equivalent to 1 by 2. Because the square root are equivalent to the power half. then this is not a quadratic, then this also is not a quadratic. I can call it generally it's not a polynomial. Okay, it's not a polynomial. The degree should always be 2 and the power variable should always be, I will remove this one. The power variable should be a positive number, should be positive. Mean if we got negative, then that is not a polynomial. It's not a polynomial or it's not a quadratic. Okay, and one more else. Number 3, because some students may be confused, then I'll write one more. The variable should not be under a radical, mean under a root. Okay, variable mean like this. Variable, what is variable? X or Y or Z. Okay, now this X should not be under root, either cube root or square root or fourth root, whatever it is. Okay, once your variable is under the root, then that also not a polynomial. Okay, variable should not be inside the root, inside the square root or inside the cube root or inside the fourth root, whatever. Once with your variables is under the root, then that is not a polynomial or is not a quadratic polynomial or not a quadratic equation. Okay, then what else we need to know from here? Okay, now I'll write one example here. Example 1 by 2x square then plus x minus 1 equal to 0. Now is this a quadratic equation or it is not a quadratic equation? Remember, don't check this number, don't check this value. Whatever the value, that doesn't matter. Whatever they put here, whether they put here a dog or whether they put here a cat. Our main aim is to check the variable, this one and this one. X, the power is 2. Got it? Degree? And here, positive. Yes. Should be a positive. The power should be positive. And here also 1, positive. Then, variable should not be inside the root. All this x is inside the root? No. Then this is a quadratic equation. Don't check this one. Any number what I put here, either dog or cat or 100 or 1000 or A or B, that will whatever, it doesn't matter. One more example. Root 3x square plus x minus 2 equal to 0. Now is this a square? Is this a quadratic equation? Yes. Because this x square is not inside the root and also it is a degree 2. And here also x power 1. Then here this root 3. This root 3 is a constant. I told you, whatever number they put here, that doesn't matter. Our main aim is to check the variables. Our main aim is to check the variables. Okay, one more. 2 by x square. 2 by x square. Then plus x minus 1 equal to 0. Now is this a quadratic equation? Maybe now you start confused whether this is a quadratic equation or not. Or I will give one more. 2 by x square. 2 by x square plus 2 by x square plus 1 equal to 0. Now is this a quadratic equation or is this a quadratic equation? Okay, I'll show you which one is a quadratic. This one is not a quadratic. This is not a quadratic equation, but this is, yes, it is a quadratic equation. Okay, now I'll explain you why this is not a quadratic equation and why this is a quadratic equation. So many types of example like this. Then first I'll explain you this two. Okay, now these are not a quadratic equation, then this is a quadratic equation. Okay, let's look why this is not a quadratic, then this is a quadratic. Okay, I'll take first this equation now. 2 by x square plus x minus 1 equal to 0. Okay, what is the standard equation? ax square plus bx plus c equal to 0. This is the standard equation. Okay, now this x square I will take it out. Remember, this x I will take it out, it will change to 2x to the power minus 2. Remember, once we take a variable of the power, if it's positive, then it will change to negative. And if it's negative, it will change to positive. That is from the law of exponential. That is a to the power n. Now, if I take this down, then it will change to a to the power minus n. Then look here, a to the power minus n. I'll take it out, it will change to positive. Then a to the power minus equal to 1 by a to the power n. This will be the law of exponential. And here, this is a to the power n, then I'll take it out and change to a to the power minus n. And here will be minus 1 equal to 0. Now, is this a quadratic? But a quadratic, I told you, the power should be positive. But here the power is negative. Then this is not a quadratic. This is not a quadratic equation. And then what about this one? Now 2x square plus 1 equal to 0. Then even this one also, if I take this x to the power 2 to the numerator, then it will change to x to the power minus 2. But here still I can multiply. Multiply throughout by x square. Okay. Multiply throughout by x square. Now if I multiply, then 2 by x into x square, multiply throughout by x, then plus here 1, and 1 into x square equal to 0 here, and into x square. And here x square and x square cancel, then we got here only 2, and plus x into 1 will be x equal to 0. Then we got here x square plus 2 equal to 0. Then we said this also we can multiply that. Yes, when we multiply this one, we got this 2, because x square and x square cancel, multiplying by x square. Then we got plus, then x into x square, it become x to the power cube. Now the degree here will be 3. Then x square into 1, we got here x square equal to 0. Now here the degree is 3, then it is not the quadratic polynomial. If you go by this also, it is not a quadratic equation. And if you multiply by what we did here also, it is not a quadratic because it's change x to the power 3. Now the degree will become 3. But here, x square plus 2 is equal to 0. Then you say, why this is a quadratic equation? Even in the quadratic equation, we have ax square plus bx plus c. But here we have only x square plus 2. But this equation, I can rewrite it in this form. Here, I told you what number is there present here, whatever it is, doesn't matter. Okay, here it is 1. Okay, x square. But here, we need bx. But here there is no x. Then I can write this as 0 multiply x. Then plus 2 equal to 0. Now compare this with this. Now this equation is same as this equation. Then this becomes a quadratic equation. You said, from where I got this? Because 0 into x will be 0. Then 0, most of the case we don't write it. 0 into x will be 0. Then no need to write it out. Then we got only x square plus 2. Then this x square plus 2 is a quadratic equation. Okay, now I understand that part. Let's look here. This question will be A. It is a quadratic equation or not? This will be yes. It is a quadratic equation. Then you said how? Again here. From denominator x is there. Then multiply here throughout by x. Multiply here throughout by x. Okay, this one. 3x. Multiply throughout by x. Okay, multiply throughout by x. Then I'll put here 3x into x. Then plus 1 by x. And put here 1 by x. Multiply again with x. I told you multiply throughout by x means we have to multiply everything. Then minus a. Then in a also we have to multiply x. Then equal 0, then 0 also multiply with x. Then here, x into x square. Then here, x and x cancel. Then we got plus 1. Then here, a into x, we got ax equal to 0. Then this will do the arrangement, and 3x minus 8x plus 1 equal to 0. Then this is in the form of this quadratic equation. Now then this is a quadratic equation. Look here, the power also 2, then the power is positive. Then this constant term doesn't matter, this 1, 3, 8, 1, whatever number it is. But the matter is this variable. Okay, then this is a quadratic equation. Then what about this one? This is a quadratic equation or not? Look here, this is x to the power 2, degree 2. But here x to the power 3, degree 3. Then the quadratic equation is a degree 3? No, then this is not a quadratic. Because due to this one, then it becomes not a quadratic. And what about this one? This is a quadratic or not? This one is similar to this. X squared plus 2, this we can write as x squared equal to, now this was a take as I change to minus, then x squared minus 2. Then this one x squared is equal to 25. And say, this one also is a quadratic equation like what this one is. Then what about this one? This is a quadratic equation or not? This obviously no. Look here, root x from the denominator, multiplying through by root x, then this root x into root x become x. Okay, where's the space? Here, right here. Now root x multiply through by root x, because here denominator is root x and multiply through by root x. Here the denominator is x multiplied through by x. Then here the denominator is x squared, then multiply through by x squared. Then here the denominator is root x, then multiply through by root x. Then root x into root x, then plus 1 by root x, again multiply root x. Multiply through by root x means everything we have to multiply by that. Then equal to 4 multiply root x. Now root x and root x cancel. Then root x into root x we got x. Then left here only 1, then equal to 4 root x. Now again this x is still inside the root, and also here the power is only 1. Then this is not a quadratic. Then this is not a quadratic equation. Then what about this one? This is a quadratic equation or not? Now here x into x, how much we got? X squared. Then obviously this is a quadratic equation. If you multiply this one, x into x, we got x squared. X into x, x squared. Then x into 2, we got 2x. X into x, x squared. Then x into 2, 2x. Now this x is finished to multiply both the number. Then now multiply this. Now 1 into x, got here x. Then this one again multiply 2. Then 1 into 2, got here 2. Then at last we got here x squared. Then 2x plus x, how much we got here? 2x plus x, 3x plus 2. Now is this in this form? Yes. Then this also is a quadratic. Then for this type equation, you don't need to multiply the whole thing. Just multiply this 2. Just look here. X into x, x squared. Then the power is 2, or the degree is 2. Then that will be a quadratic equation. Then what about this one? This x plus 2 whole thing cube equal to x cube minus 4. Is a quadratic or not? Then here also it is a quadratic equation. Okay, let's explain why this is a quadratic equation. Okay, now x plus 2 whole thing cube is equal to x cube minus 4. It is a quadratic. Why? Even here also x cube, but this is not a quadratic. Here the degree is equal to 3, and this is not a quadratic, because the quadratic the degree has to be 2. Even here also the degree is 3. Then you may say that this is not a quadratic, but this is a quadratic. Okay, I'll show you why. Okay, x plus 2 whole thing cube equal to x cube minus 4. Now we have a formula of a plus b whole thing cube. If you know this, a plus b whole thing cube is equal to how much? This is equal to a cube plus b cube plus 3ab into a plus b. We have this formula. Okay, then I'll use that formula. Here. This x will be as a, we got here x cube, then plus b cube, b here will be 2, a plus b, then a cube plus b cube, then plus 3, what is a here? X. This 3 is from here, from this formula. From where is 3 here? From this formula. Then 3ab, what is b here? 2, then a plus b. Then this is equal to x cube minus 4. Okay, here also x cube and here also x cube. This is positive and this also positive. Now this plus, if I take this side, will change to minus. Then x cube and x cube will get cancelled. Then x cube and x cube get cancelled. Now what left? 2 to the power 3 will be a. Then plus 3 to 2, 6. Then we got here 6x. Then x plus 2 equal to minus 4. Now left only minus 4. This x cube and x cube are cancelled. Then we got here this minus 4, if I take this side, will change to plus. Then 4 plus 8 become 12. Then we got here, okay, 6x. Then we got 6x squared. X into x, x squared. Then plus 6 into 2, 12. Then this x, put it as it is. Then this 8, this minus will take this side, change to plus. Then 8 plus 4 become 12 equal to 0. Now look here. X squared, x and constant. Is this a quadratic? Yes. Then here this is a quadratic equation. Got it? Okay. Then I'll give you some more example from your textbook. I'll take one question from your textbook. That will be exercise 4a. Question. Okay. Question. Which question I'll do for you? Question number 1. Okay, question number 2. From your textbook, exercise 4a. Question number 2. Exercise 4a, question number 2. That will be given as like this. X squared minus, they give like this. X squared minus 1 by x squared is equal to 3. Is equal to 3, provided that x should not equal to 0. What is the meaning of this? Because if I put here in place of this x with 0, then 1 divided by 0, what's the answer? If I put x is equal to 0, then here we got 1 by 0. What's the answer? There will be no answer. Here will be no answer. Or undefined. Undefined means this 1 by 0 is not yet known what is the answer. Then that's why x should not equal to 0. Okay, now this question is a quadratic equation or not? Look, from denominator x squared and multiplying through up by x squared. If I multiply through up by x squared, here is already x squared is there. Then x squared again multiply x squared. X squared again multiply x squared, we have x to the power 4. Then x to the power 4 is a quadratic equation or not? The degree of a quadratic should be 2, but here the degree is 4. Then this is not a quadratic equation. Got it? Okay, some more example from your textbook. Question. Okay. Question number 1-6. Question number, same exercise. Question number 1-6. I give x squared minus 4x. X squared minus 4x is equal to x squared minus 2x. Now, do we ask this is a quadratic equation or not? By looking here, x to the power 2, mean the degree 2. Then obviously you said this is quadratic equation. But no, this is not a quadratic equation because here is also x squared and here also x squared. This is plus and here also plus. Now, this plus if I take this side change to minus, then x squared and x squared will get cancelled. X squared and x squared get cancelled, then there is no more x to the power 2. Then the degree is reduced to 1. Right? then this is not a quadratic equation. Because the quadratic equation we need x to the power 2. Okay, then this question, exercise 4a, question number 1, 2, 3. Exercise 4a, question number 1, 2, 3. Please do it. Okay, try it by yourself. This will be as your exercise for you. Okay, now come to next part of this, again from this chapter. Next part from this same exercise, that will be question number 4. And before we start the question 4, I'll give you some example. Then after that, we will do the rest. Okay. Now we'll start the next part. Okay. And this exercise for A, question number 1, 2, and 3, you try it by yourself. And now we'll explain that types of question, and before we go that, let's understand first what is the solution. Okay. Solution. Most of the cases ask find the solution of this equation. If they give you some equation, they ask find the solution, or find the zeros, or find the roots of the equation. Okay, find the zeros, find the solution, or find the root. That will be same process. Okay. Now look here. If I give f of x is equal to ax, mean f of x is equal to ax, then if I ask you what is the solution of this equation, means what's the solution? The solution means I have to get f of x is equal to 0. If I don't get x of x is equal to 0, the value what I get is not the solution. Okay, then here, then ax is equal to 0. Then I got here x is equal to 0. Then x is equal to 0. 0 is the solution of this equation. Okay, I'll give you another example. F of x is equal to ax. Okay, I'll put here with x minus 4. Then what's the solution of this? The solution of this means I have to get the whole equation equal to 0. Then only it become the value, it should be the solution. Okay, then here to get 0 means I have to get f of x is equal to 0. Then f of x is x minus 4. Then you got here x minus 4 equal to 0. Then this minus I'll take it aside, change to, then x is equal to 4. Then 4 is the solution. Then 4 is the solution of this equation. If I put here, in place of this x, what I put here? 4. Then 4 minus 4 become 0. 4 minus 4 become 0. Then now, if, look here in this equation, check which of the given values are the solution of the equation here. This x square minus 3x plus 2 is equal to 0 and the equation. And they give the value of x is equal to minus 2 and x is equal to 1. Is this minus 2 is the solution of this or not? Then is this 1 is the solution of this or not? To check that whether this minus 2 and 1 is the solution of this equation, given equation, means we have to get the whole equation become 0. Okay, now let's take this question. X squared minus 3x plus 2 equal 0. Okay, no need to write the 0 here also for calculation. Okay, now they give x is equal to minus 2. Then after that, I write here. And x is equal to minus 2. What they give here? And x is equal to minus 2. Let's check this minus 2. Is the solution of this or not? Is the solution or not? Okay, then in place of this x, what I have to do? I have to substitute in minus 2. In place of this x, I have to substitute in minus 2. Okay, let me take this equation as f of x. Let me take this equation as f of x. We just assume whether f of x or p of x or q of x, g of x, whatever you represent it, and represent it f of x. Okay, then I'll put here f of, what's the value of x? Minus 2. Okay, then in place of this x, I'll put minus 2 whole thing square, because here there's a square. Then minus 3, yes, minus 3. Now this is x. And in place of x, minus 2. In place of this x, we have to substitute with this minus 2. Then here there's no more x, then just write this value plus 2. Let's do the calculation. Then 2 to the power 2 will be 4. This minus will disappear if the power is even number. This minus will disappear if the power is even. But if the power is odd, then this minus will become here. Okay. Then minus minus plus. Because here the power is odd. Then odd, then the negative will come out. Then that's why I do minus to minus plus. But if here is a power even, then this minus will disappear. This minus. Then 3 to 2, 6 plus 2. We got here 12. Now did we got 0? Did we got f of minus 2 is equal to 0? No. And since 12 is not equal to 0, since 12 is not equal to 0, then x minus 2, this x minus 2 is not the solution. Means because you have here f of minus 2 is not equal to 0, then x is equal to minus 2 is not the solution of this equation. Okay, let's check this x is equal to 1. Okay, and x is equal to 1. And x is equal to 1. Okay, let's check. Then f of how much? F of 1. F of 1 equal to f of 1. Now in place of this x, how much we have to put? 1. 1 square, because here is x square. Then minus 3x, x is 1, then plus 2. Then how much we got here? 1 square will be 1, then minus 3, then plus 2. Then 1 minus 3 we got minus 2, then plus 2, then minus 2 and plus 2 we got 0. Then here f of x is equal to 0. Now we got 0. Then what does it mean? Now this x is equal to 1 is the solution of this equation. X is equal to 1 is the solution. But x is equal to minus 2 is not the solution. Only x is equal to 1 is the solution. X is equal to minus 2 is not the solution of this. Now similarly for this one. Okay, now let's look at this question. Which one from here is the solution of this equation? Solution means the answer, I can say. Okay, question number B. Number B, x square minus 3 root 3, x square minus 3 root 3x, then plus 6 equal to 0. Then we have to check whether this is a solution or whether this is a solution, or it may both be solution. Okay. Let me take this. Let me take this as f of x is equal to x squared minus 3 root 3 x plus 6. Okay, I told you to know that whether this is the solution or not, we have to get f of x is equal to 0. Okay, then and x is equal to how much? What is the value? Minus 2 root 3. Okay, and x is equal to minus 2 root 3. Okay, let's take now. F of x. Then in place of this x, I'll take this minus 2 root 3. Then equal to. Now in place of this x, we have to substitute by this. Then in place of this x, I put 2 root 3 whole thing square, because here is a square. Then we cannot just leave the square. Then minus 3 root 3. Then in place of this x again, we have to put minus 2 root 3. Then minus 2 root 3. Then plus 6. Okay, and how much we got here? I told you, whenever the power is even number, then the minus will disappear. And here will be no more minus. Then 2 to the power 2 will be 4. 2 to the power 2 how much? 4. Then root 3 to the power 2 how much? Root 3 to the power 2 is 3. Because root 3 into root 3 equal to 3. Then this root 3 to root 3 means root 3 whole thing square. Then root 3 whole thing square is equal to 3. Then here we got 2 to the power 2, 4. Then root 3 to the power 2 we got 3. Then 4 into 3 we got how much? 12. Then this minus 2 root 3 whole thing square, we got 12. Then here minus into minus, we got here plus. Then 3 into 2, how much? 6. Then root 3 into root 3, 3. Then 6 into 3, we got 18. Then we got here plus 6. Then 18 plus 18 will be 36. Then we got here f of minus 2 root 3 is equal to 36. Did we got equal to 0? This is not equal to 0. Then what we write here? Hence, x is equal to minus 2 root 3 is not the solution. Look, I told you, this value to become a solution, we have to get here, how much we have to get? 0. But here we don't get 0, we got 36. Then this minus 2 root 3 is not the solution of this equation. Okay, then next, x is equal to root 3. Okay, then add x is equal to root 3. Let's take this one. Then therefore f of in place of this x, what you have to put? Root 3. Then in place of this x, root 3, but square is there, and I put square. Then minus 3 root 3 into root 3. In place of this x, we have to put root 3. Then plus 6. Then here, what we get? Now root 3 whole thing square, I told you how much we got? Root 3, 3. Then root 3 whole thing square also 3. Then here root 3 whole thing square, we got 3. Then minus. Now root 3 into root 3. Root 3 into root 3, 3. Then 3 into 3 will be 9. Then plus 6. Then 3 minus 9, we got here minus 6. Then plus 6. Then we got 0. Now what we get? F of root 3 is equal to 0. Then here it's not equal to 0. Then root 2 minus 2 root 3 is not the solution. Then here, hence, x is equal to root 3 is the solution. Is the solution of this equation. Now you got it. Then this question also you can write like this. Then now the question from exercise 4a. Now exercise 4a, question number 4. This also you do by your own, because this is same process like this one only. This question I've taken from your textbook only, from exercise. Then now we'll come to next part of this exercise, and only question number 5. Okay. Now we finished just now which are check whether the equation are a quadratic equation or not. Then the solution of the equation, which of the following and which of the given values are the solution. Solution means we have to get the whole thing equal to 0. Then here we need to find the unknown value, that will be k, to write this question. Determine the value of k. We need to find the value of k for which the given value is the solution. Solution means everything has to be 0. The whole equation should be equal to 0. Okay, example like this one. They are all given here equal to 0. Then question number 8, solution. Then kx square minus 3x plus 2 equal to 0. They only give that x is equal to 2 is the solution. Is the solution means the whole thing should be equal to 0. Then here is only equal to 0, then we don't need to write again. Then we just substitute what's the value of x, what we give the value of x. What's the value of x? And x is equal to 2. Then okay, now this k, now in place of this x, what we have to put? 2. Then I'll put here 2 whole thing square, then minus 3. Then in place of this x, how much we have to put? 2. Then plus 2 equal to 0. Then here we have 2 to the power of 2 will be 4. Then 4k, then 6, then plus 2 equal to 0. Because 3 into 2 will be 6. Then then 4k, then minus 6 plus 2, we got minus 4 equal to 0. Because minus 6 plus 2 will be minus 4. Then here 4k equal to this minus, if they can change to plus. Then here 4 and 4 will get cancelled. Then what left now? K is equal to 1. What's the value of k? 1. Because, or if you are confused to do by this cancellation, then I will write it. And this 4k is equal to 4. Then I will write this. K is equal to, this 4 is already here. Then this 4 from here, it will go there and do the division. Then 4 divided by 4 will get how much? 1. And k is equal to 1. That will be the answer. And this question are very, very simple. Okay, let's look this next question will be k x squared plus 3x plus 3ax plus k. X squared plus 3ax plus k equal to 0. They give us what is the solution of this equation? Minus a. That is the solution. They said is the minus a is the solution of the given equation. Then this is the equation. Then these are the solution. Okay. Then I'll put here and x is equal to minus a. Now look at this. Then in place of this x, what we have to put? Minus a. Then put here minus a whole thing squared. Then plus 3a. Then in place of this x, again have to put minus a. Because this a is already there. Then in place of x, minus a. Then plus k equal to 0. Okay, now how much we got? How much will we get? Okay. I told you, when the power is even number, then the minus will disappear. Then we will have here only a square. Then minus, because here is power is odd, then this minus will never disappear. Then minus into plus, minus, then a into a will be a square. Then we got here 3a square. Then plus k. Plus a equal to 0. Then how much we get now? Now here is, look, whenever there is no number, then here will be what is present? 1. Then 1 minus 3, how much you got? Because here also a square, here also a square, same parameter or same variable. Then 1 minus 3 will be how much? Minus 2. Because minus 3 is greater than, because the magnitude of minus is greater than magnitude of plus. Because here the magnitude of minus is 3 and here the magnitude of plus is only 1. Then the minus is greater than plus, then minus will come here. Then 1 minus 3 will get minus 2. Then a square plus k equal to 0. Then this minus will take this side change to plus. Then therefore k is equal to a square. Now this will be the answer for this question and this question. Now here we got k is equal to 1 and here we got k is equal to 2a square. Okay. Then again from your same exercise 4a, question number 6. Question number 6 you will do by yourself. Now I'll do for you the last question number 7 and question number 8. But this question number 7, question number 8 is not that much, it's not important for your exam. Or maybe there's a chance of getting, they will set this question. But maybe this year 2022 I don't think so. Okay, question number 7. Okay, now let's do this last question and exercise 4a from your textbook. Okay, question number 1, 2, 3, 4, 5, 6. This already finished to explain. 1, 2, 3, 4, 5, 6 already finished to explain, and please do it by yourself as according to your exercise 4a. And this question number 8 also you do by yourself. But this question number 8 explanation, this question number 8 will be question number 7. Because 7 and 8 are the same question. Only the number are changing. Mean I can say they are the same game, 7 and 8, but only the player are changing. Okay. Then find values of a and b. For which x is equal to 3 by 4. In this question we need to find the value of what? A. We need to find the value of b. We given, look, in last question we find the value of only one unknown, that is k. only one unknown, that is k. But here there are two unknowns, a and b. Remember, whenever one unknown, we need one equation. Whenever there are two unknowns, we need two equations. Whenever three unknowns, we need three equations. Then here look, they given two unknowns. Then look how many equations they give. 1 and 2. Mean, look, whenever three unknowns, four unknowns, then equation also should be three equation, four equation. If you need to find two unknowns but you have only one equation, that is not possible. Okay, then if they give you two equations but there are three unknowns, then that also you cannot find by only two equations. Then here, how to get that two equations? You look from here. Look, we need to find values a and b for which x is equal to 3 by 4. This x is equal to 3 by 4 is the solution of this. Is the solution. Then and x is equal to minus 2 also is the solution. Mean this x by x is equal to 3 by 4 and x is equal to minus 2 are the solution of this equation. Mean both these two values are the solution. But given here are the roots. I already told from you zeros or root or solution. They are almost like the same only. If they said are the root, means same as the solution only. Okay, don't confuse if they say root or if they give solution. If they give roots or zeros or solution, the whole equation should be equate to 0. Okay, solution for this question. Okay, I'll do like this. Given equation ax squared plus bx minus 6 equal to 0, and we give this equation it has also a solution of at x is equal to 3 by 4 and x is equal to minus 2. That are the two solutions or the two roots. And then we need to find a and we need to find b. Okay, now we start to solve this. Question number 7. Find the values of a, b. Okay. Now, I'll start first with this one. And x is equal to minus 2 or x is equal to 3 by 4. We can take anyone at first. Okay, I'll take first this at x is equal to minus 2. Or I can take this x is equal to 3 by 4 also same. You can take this one and x is equal to minus 2. I'll take first with this. Now do like this. Now in place of this x, what we have to put? Minus 2. And you got here a. Now in place of this x, how much we have to put? Minus 2 whole thing square, then plus b. Now in place of this x, we have to put minus 2. Then this minus is from the left side, and I'll take it to the right side and change to plus. Then what we get here? 2 to the power 2, we got 4. Then 4a, then minus 2b equal 6. Now I told you whenever the power is even number, then minus will disappear. That's why there's no more minus here. Then here will be the power is odd, then minus still there, and minus to cross would be minus. Then here I can take common as 2. And take common 2, then I got here 2. Now 2 into 2 we got how much? 4. Then minus 2 into b, we got 2b equal to 6. Now 2 into 1 and 2 into 3, 6. Then I can write that is, I'll take this minus b this side. Then I got here 2a. Now this plus 3, I think this side change to minus. Then I got here b. Then I can interchange this one. b is equal to 2a minus 3. Then put this as equation 1. Okay. Then also, now we already take at x is equal to minus 2. Then now we don't have any option, and I'll take this at x is equal to 3 by 4. And also at x is equal to 3 by 4. Now we got one equation. I told you whenever two unknowns, we need to find a and b. There are two unknowns. Then we have two equations. Then we only got one equation. Now we need to find one more equation. Okay. Then in place of this x again, we have to put 3 by 4 whole thing square. Then plus. Now in place of this x will be 3 by 4. Then this minus, I think that's I change to plus. Then we got here 3 to the power 2 will be 9. Then 9a by 16, because 4 to the power 2 will be 16. Then here plus 3b by 4 equal to 6. And here, what I'll do? What you have to do here? Okay, we'll find the LCM. 16, 4. Now 2 into 8, then 2 into 2, then 2 into 4, then 2 into 1. Then what is the LCM here? 2 into 2, 4, and 4 into 4, 16. 16 is the LCM. Then I'm multiplying throughout by 16. Multiply throughout by 16. So here LCM is equal to 16. 2 into 2, 4, 4 into 4, 16. Then multiply this throughout by 16 and what is 9a. 16 will be no more. Okay, I'll show that one. 16 into 16. Because multiply throughout by 16, I have to multiply by 16. Then 3b by 4, then I multiply by 16. And here also multiply by 16. Then we got here 16 and 16 cancel. Then we got here 9a. Then plus 4 into 4, 16. Then 3 into 4, we got 12b. Then equal to 6 into 16. Then here we can take common something. We can take common, what do you have to take common? 3. Okay, now 3 again, right? 3. Now 3 into 3, 9. Then plus 3 into 4, 3 into 4, 12. Then we got here 6 into 16. Now 3 into 1, 3. Then 3 into 2, 6. Then we got here 3a plus 4b is equal to 2 into 16 will be 32. This would be the equation 2. Now we got 2 equations, then we need to find 2 unknowns. Then, now which method we'll use? Okay, we'll solve. There are 3 methods: substitution method, elimination method, and cross multiplication method. That will be CMM. Cross multiplication method. Okay, but this method that you learned it in chapter 3, that in previous chapter. Okay, but here I will do by substitution method. Or if you like elimination method, we try elimination method. If like cross multiplication method, we try that one. Those who know those methods, then you do it. Okay. Now I'll use substitution method. Then I will like this. Substitute this equation 1 in equation 2. I'll write like this. Substitute equation 1 in equation 2. Or I can substitute the value of b in 2. Then go here. Now 3a plus. Now in place of this b here, how much we got here? 2a minus 3. Then I put this 2a minus 3 in place of this b. But this 4 we cannot throw it out. We cannot take it and put inside our pocket. This 4 will remain as it is. Only this b will replace by 2a minus 3. Then equal to 32. Then we got here 3a. Then 4 into 2 will be a. Then 8a. Then 4 into 3 will be 12. Then equal to 32. Now this is a and here also a. Then here there's no a. Then this is no a, then take it together with this no a. Here also no a, here also no a. Take them together, and here is a, then put them together. Then 3 plus 8 will be 11, and we got here 11a. Then this minus will take that side will be plus. Then 32 plus 12 will be how much? 44. 44. Then 11 into 1, 11 into 4, and we got here. Therefore, a is equal to 4. Now we got value of a. But the question said find value of a and b. Then we need to find value of b. Okay, I'll find the value of b here. Okay, then put a is equal to 4 or substitute a is equal to 4 in equation 1. Put a is equal to 4 in equation 1, then what that is? B is equal to 2. Now in place of this a, how much I have to put? 4. Then 4 minus 3. Then this will be a minus 3 is equal to 5. Now we got value of a 4, then we got value of b 5, then thus a is equal to 4 and b is equal to 5 will be the required answer of this question number 7. Then this question number 8, please try it by yourself from your textbook question. Okay. Then thank you. This will be the whole exercise for A. Then in next class we will continue with exercise for C. For B is not important. Then we'll jump back into exercise for C and for D. Thank you.